This is a lesson in Unit 4, Modeling with Functions, Student Learning Task 2, Analyzing the Graphs of Combinations of Functions. Before we get into today's lesson on analyzing graphs of combinations of functions, I would like you to please write down and answer these two questions. You should pause the video at this point. Okay, it says make conjectures, support your answer algebraically with symbols and also graphically. What happens when you add a parabola and a line? So what I'm going to do for number one is I'm just going to randomly come up with a parabola, any algebraic parabola. So I'm going to use y equals x squared plus 2x plus 3. And the line I'm going to add to that is going to be y equals 4x plus 5. Okay, so when I add these two together, I don't know what's going on here technically. Whoa, hopefully this will keep working. Put this back on. Okay, so if I add these together, let's everyone say a little prayer. I'll get x squared plus 6x plus 8. So if I add together a parabola and a line, it is still a parabola. Okay, so it says what happens when you take the absolute value of a parabola. Oh, we didn't do this graphically, so let's do that. So let's say I have a parabola that's just regular old x squared, and I add a line to it. If I add, let's say this was x, y, and then the other y, so like let's say the first one we've got -2, -1, 0, 1, 2, and squared would be 4, 1, 0, 1, 4. And then our line, let's just say for fun that was like 1x minus 2. That looks like it could be 1x minus 2. So this would be -2. This would be 0. This would be, oops, not 0. That would be -1. This would be 0. This would be -3. And this would be 3. So let's see. No, not 3. What am I talking about? -4. So if I added these together, let's see. I would get 0, -2, -2, 0, 4. Huh. Interesting. Let's see. If this was -3. Just I want to see if this is a 4. I want to see if I can get a 4 on the other side. So -3 squared would have been 9. And back up my slope, that would have been -5. And then 9 plus -5 would have also been 4. So you can see that this, if I went and graphed it, I would still have a parabola. Okay. Number 2 says, what happens when you take the absolute value of a parabola? Well, if I took the absolute value of a parabola, I'm going to take a parabola and I'm going to give it some negative y values. So here we go. If I took the absolute value of it, because absolute value is just the distance from 0, it's going to take all the points below the x-axis and flip them over an equal distance above the x-axis. And then this would be the absolute value of our graph. So like let's say this graph had a vertex of like 3, -1. We would write this as y equals the absolute value of x minus 3 squared minus 1. All right. So what I'd like you to do is please turn to page 9 and just read the scenario at the top of page 9. Okay, so we have a set of equations here, and what we're going to do is we are going to be combining two functions. So the first roller coaster we're looking at is called the mountain climb. Now, I will give you the hint that the name of these roller coasters is going to give you an idea of what they are going to look like. So what we are doing is we are going to add a sine function that is periodic with an amplitude of 5 with a line that has an increasing slope of 2. And think about it, this one is called the mountain climb. So what do I think the mountain climb looks like? If I took a line and I took a sine function and I added them together, what would it look like? If you thought it would look like this, you are correct. And so my explanation is going to be y equals 2x is the new midline, because that's what we are adding to our sine function. So what I'd like you to do is I'd like you to pause the video, work through the proposals 2 to 5, think about the name, think about what you are doing to the functions, if you're adding them, if you're taking the absolute value of them, and what they would look like. Then go ahead and unpause the video and I'll share my predictions with you. Okay, at this point you should have worked through proposals 2 through 5. Proposal number 2 is called the periodic bump. So if you think about the name periodic bump, we're going to take a sine function and we're going to take the absolute value of that. So instead of the graph looking like this, the graph is going to look like a bump, bump, bump. This looks like I would throw up. I would not want to ride this ride. And my explanation is going to just be the absolute value reflects the negative y values over the x-axis. Okay, so for proposal number 3, that one is called the amplifier. So if you think about what an amplifier does, it makes something bigger. And so what I'm going to do here is I'm going to take a sine function and I'm going to multiply it by x. As x gets larger and larger, the sine function's amplitude is going to get larger and larger. So the graph should look like that. And my explanation is going to be the bigger x gets, the larger, the product of x times sine x will be. Okay, the gentle wave. So if you think about what a gentle wave roller coaster might look like, it's just going to be like a really small, light wave. And also, if we look at this, we see we've got a basic sine function. And then over here, we've got an exponential decay. And we are multiplying these together. So we have something that oscillates, the y values being multiplied by something that's getting smaller. So the gentle wave might start off larger, but as it goes on, it's going to get smaller and smaller. And my explanation is going to be that the decay function makes the product 10.9 to the power of x times sine x grows smaller as x increases. All right, so the last one is called the spinning high dive. We got a lot going on in this spinning high dive. The spinning high dive has 100 minus a parabola plus a sine function. And pretty much there is a lot going on here. So my graph, I just kind of drew like a crazy graph. And my explanation literally was just, there is a lot going on. I was just like, ooh. There are 3 functions added together. All right, so now what we're gonna do is we're actually gonna pick up our calculator, and you need to set up your calculator a specific way. Go ahead, turn on your calculator. We're going to put these graphs on pages 13 and 14. You're going to use those grids to help you set up your windows. So if you look on page 13 and 14, you can see you've got an X minimum and an X maximum. Like that first one starts at 0, and I believe it goes up to 20 on the X, but it goes up to 40 on the Y. So hit window, change your window so your window matches the window on page 13. Make sure you are in radian mode. So again, you're going to write your graphs on 13 and 14, and then you're going to record your thoughts on pages 10 and 11. I'm going to put my graphs on pages 10 and 11. So, for example, when I go to graph that first equation, the mountain climb, I see that I've got, I'll just do that with you. Let me get my calculator going here. Here comes the calculator. There we go. I'm going to go to y equals. And hit clear. I'm going to go 5x. Or was it 5x? No, it was 2x, sorry. 2x plus sine 5 sine x. Make sure I'm in radian mode. I am, and then I'm going to hit window. You can leave the X min, it doesn't really matter, but I need to make my X max 20. I need to make my Y max 40, because that's what the grid I see. And then I'm going to hit graph, and sure enough, there is my cute little mountain climb. So go ahead and just put a sketch of that, make it kind of accurate on page 13. And go ahead, pause the video, and do that for all 5 graphs. Okay. So here is what the mountain climb looks like. And were we correct? Yes! Adding a line to a sign creates a sign with a line, sounds like a Dr. Seuss book, a line for its midline. It's a lot of lines. Okay, so the periodic bump. If you graph the periodic bump, it should look like this. And please make sure your graph bumps up to 10, and you notice that each bump is at pi. So like that's 3, so because then the period would have been 2 pi when this one was underneath. And again, we were correct. Looks pretty good. Maybe I'm gonna make a little note. It goes up to a maximum of 10 because that is the amplitude. Okay, the amplifier. When you graphed that, it should have looked similar. And what features I got right and what I missed. My shape looked right, but I forgot I did not give my graph negative y values. And I needed to do that. Maybe I guess this one goes underground. Maybe there are some tunnels. Okay, the gentle wave. There's our gentle wave, and it looks pretty good. I brought my wave down a little too quickly. So I'm just gonna make a little note. I made my graph amp decrease too quickly. And now I really had no idea what to put for proposal number 5, the spinning high dive, so I was curious to graph that one, and I was really surprised to see that it looked like that. That just wasn't what I would expect. But then the closer I looked at it, when I looked at the equation, I really realized this is the addition of the parabola 100 minus x squared and a sine function. So the parabola becomes the midline, and the parabola opens down, has a y-intercept at 100, so that one I was pretty wrong on. All right, your job now is to work on pages 15 to 19 and to match the formula with the appropriate graphs. Describe the features that you use to help you so, for example, here are the equations, here are more equations, and here are the graphs that you are to match with.